In this video, I'd like to show you some information about equations with just one variable, just x's, no other letters, just one variable, and these equations have no possible solutions, which seems kind of strange. We get in the habit of solving equations all the time, x equals a certain number, but it turns out there's a certain group of equations where there are no possible solutions. So you've got your assignment, you're cruising along, you've come to an equation like this, and you're solving it the way your teacher has shown you to solve them. And I'm going to separate the two halves, and I want to get rid of the x term on one side. So I only have an x on the left, get rid of the numbers on this side, and so I start going. What's the opposite of minus 4x? Well, that's plus 4x. And negative 4x plus 4x cancels. So if I add 4x to one side of the equation, better add 4x. Plus 4x to the other side. And that's when something weird starts to happen. Negative 4x plus 4x, well, just like over here it canceled, it's 0, 0x or just 0. Well, negative 4x plus 4x is 0x over here too, or just 0. So what's left? Negative 2 is on the left is equal to 10 on the right. Negative 2 is equal to 10. Your first reaction is, huh? What's going on? Negative 2 clearly does not equal 10. I know that something weird is going on here. I know this is false. But what's going on? Negative 2 can never equal to negative 10. If you come up with a situation like this, you have found yourself an equation that has no possible solutions. And I look back at the original equation and I see the x term on both sides. It's the same x term with different numbers. When these x terms cancel out, it leaves these different numbers on either side of the equation. Something weird is going on here. So is it really true that there are no possible solutions? There's no possible value for x? Let's just test a couple to see if that really is true. So here's that same equation. Negative 4x minus 2 is equal to negative 4x plus 10. I wrote it 3 times. Let's test it for when x is equal to 3, when x is equal to 4, and then let's throw in a negative just to see if that would work. What happens when x is equal to negative 2? So let's try it. Let's substitute 3 in for x, wherever x appears. So we have negative 4 times 3 minus 2 is equal to negative 4, instead of times x, it's times 3, plus 10. If I do the multiplication first and the addition and subtraction second, I get negative 12 minus 2 and negative 12 plus 10. And negative 12 minus 2 is negative 14, and negative 12 plus 10 is negative 2, and sure enough, when x is 3, the two sides of the equation are not equal. X equals 3 is not a possible solution. Let's just try another. What if x is equal to 4? If I substitute 4 in, I'll have negative 4 times 4 minus 2, negative 4 times 4 plus 10. Let's do the multiplications and the addition and subtraction. So I'll have negative 16 minus 2, negative 16 plus 10. Negative 16 minus 2 is negative 18. Is this negative 18? Let's see. Negative 16 plus 10 is negative 6. No, 4 doesn't work either. Negative numbers. Maybe this one will work. Let's put negative 2 in for x wherever it appears, and I've got negative 4 times negative 2 minus 2. And negative 4 times negative 2 plus 10. Do the multiplication, the addition and subtraction. That is a positive 8 minus 2 and a positive 8 plus 10. And 8 minus 2 is 6, and 8 plus 10 is 8. 15, and still it's not working. And I could keep trying over and over and over. The infinite number of possibilities I could put in for x, none of them will ever work. This equation has no solutions, which is kind of weird. So what's going on here? How can we identify this? How can we explain this? How an equation can have no solutions? Well, here are a couple things that we want to notice about the equation. When we just look at this original equation, negative 4x minus 2 is equal to negative 4x plus 10. First thing we notice, the x terms on either side are exactly the same. Negative 4x, negative 4x. The other thing I notice is the numbers are different. Negative 2 and positive 10. So, as I wrote here, when you solve the equation, like I did over here, the x terms will cancel out, leaving different numbers on each side of the equation. Negative 2 equals 10. Clearly that isn't true. So, if the x terms on each side of the equation are the same, and the numbers are different, then the equation will have no solutions. Because you end up with this false statement of negative 2 is equal to 10, or whatever your equation is, you'll have two different numbers that clearly are not equal to each other. So this has no solutions. So you can identify these right away, hopefully, with this information. If I put a few equations in front of you, can you identify which of these equations have no possible solutions? No possible solutions? That word should not be there, sorry. If I look at these, remember what the rules are here. If the x terms are the same on both sides but the numbers are different, we're going to have no solutions. So first one, x terms are the same, numbers are different. This equation is going to have no solutions to it. How about this one? Ooh, x terms are different. So this one is not going to fall in that same category. This one is a different type of equation. Here, last one, x terms are the same, but the numbers are also the same, which also puts this in a different category from this type of equation over here. Let's see what's going on here. If I try to solve this first one, as predicted, the x terms cancel away, and we're left with 5 is equal to 4. Clearly that is false, so we know that this equation has no solution. No matter what value you try for x, the two sides will never ever be the same. On the next equation, this one is not going to be in the no solution category. If you try solving this one, this is the type of equation you see most of the time. When you solve it like your teacher has shown you, you get rid of the x term on one side, you get rid of the numbers on the other side, you end up with x is equal to 2. Well, that is a one solution type of equation. For this equation, the only possible number that works when you substitute it in for x is that 2. And finally, over here, what happens when the x terms are the same and the numbers are the same? When you solve it, the x's cancel away, the numbers cancel away, leaving you with 0 equals 0, which is pretty boring, but it is always true. It doesn't matter what value you put in for x. That equation will always result in negative 8 equals negative 8, or 0 is equal to 0. The x's don't matter because they cancel out right away. So I hope that helps. I hope that helps in showing you what kind of equation you're dealing with when you have the x's the same but the numbers different, and why that results in no solution. I will also have links on my video, links to a video that I made about one solution type of equations and infinitely many solution types of equations, so you can check out those videos if you are curious. I hope it helps.